and welcome to the show Crack the 7. In this show we are having discussion on the Avogadro's number. It's a big count, very big count. The value of Avogadro's number is 6.022 into 10 raised to 23 and this value found experimentally. This value is having a relation with the chemical molecules. What is the relation? What is that relation we need to understand very first. The relation of Avogadro's number and the mole is 1 mole of any species is 6.022 into 10 raised to 23. This particular value has a particular coding which we call NA. NA is a symbol given for the Avogadro's number. So the relation is exactly 1 mole of any species is equal to 6.022 into 10 raised to 23 number of that particular species. It is also equal to 22.4 liters of any gas when the gas is kept at standard temperature and pressure, and it is also equal to the gram molecular mass of that particular species. What is gram molecular mass? Gram molecular mass is the mass of the molecule, molar mass of the molecule expressed in the grams. So this is all about the relationship between the Avogadro number, mole, volume and gram molecular mass. This Avogadro number has wide range of applications. Whenever we need to find the number of molecules reacting in the chemical reactions or number of molecules obtained from the chemical reactions, we need to use this Avogadro's number. So it is very wide application and many questions are asked in the JEE and NEET examination that use the Avogadro's number. So let's start today's show, that is Avogadro's number, the big count, Crack the 7. The show question 1 level 0 and the question is: the number of atoms in 12 gram carbon 12 has been found experimentally and the number is 6.022 into 10 raised to 23. This number is also known as option A, Avogadro's number, option B, Ostwald's number, option C, Perrin's number, option D, Dalton's number. Dear friends, this number was invented by Perrin, but it is given name for the Avogadro's great contribution and therefore the number is called as Avogadro's number. So the correct answer is Avogadro's number and option A is the correct answer. Now presenting second question level 0 and the question is: Avogadro's number is representing option A, 1 mole of any species, option B, gram molar mass of any species, option C, 22.4 liters of any gas at STP, that is standard temperature and pressure. All of the above, that is option D. Dear friends, as per the Avogadro's law, any substance which is 1 mole, which is having a volume 22.4 liter and it is a gas at standard temperature and pressure, and any species which is having a gram molar mass is called as Avogadro's number. So Avogadro's number representing all of these three, and therefore the correct answer is option D, that is all of the above. This is very important fact and you need to remember for whole course of class 11 and class 12, which will help you a lot in solving many numericals in future. So the correct answer for this question is option D, all of above. Now presenting third question level 1 and the question is: in 1 mole of barium chloride, how many atoms of barium and chlorine are present? Options are Ba is equal to Na and Cl is equal to 4 into Na. Option B, Ba is equal to Na and Cl is equal to 3 Na. Option C, Ba is equal to Na and Cl is equal to 2 Na. Option D, Ba is equal to Na and Cl is equal to Na. Dear friends, let us understand what is Na. Na is representing or a code given to the Avogadro's number. So Na is equal to the value 6.022 into 10 raised to 23. Now what is BaCl2 molecule? Let's understand. BaCl2 molecule has one barium atom and two chlorine atom. So when we take 1 mole of BaCl2, it represents that 1 mole of Ba is present and 2 mole of chlorine atoms present. And we know that 1 mole is equal to Avogadro's number. So the correct answer for this question is option C, that is Ba will be Na and Cl will be 2 into Na. So the correct answer is option C, that is Ba is equal to Na and Cl is equal to 2Na. Now presenting question number 4, level 1, and the question is: the charge of one electron is 1.602 into 10 raised to minus 19 coulomb and Faraday's constant is 96500 coulomb, that is 1 Faraday. What is the relationship between the two when Avogadro's number is in the role play? Options A, Avogadro's number into charge is equal to 1 coulomb. Option B, Avogadro's number into 96500 is equal to charge. Option C, Avogadro's number into charge is equal to 1 Faraday. And option D, Avogadro's number into charge is equal to 10 coulomb. Dear friends, first of all, we need to understand, or we need to remember that one electron, single electron charge is 1.602 into 10 raised to minus 19 coulomb. So it is given in the question. Now, what is the coulomb? What is the 96500? 96500 is the value we call Faraday's constant. So here in the question it is asked that what is the relationship between these two. Now if we multiply charge with the Avogadro's number, that is 6.022 into 10 raised to 23, we get the value approximately equal to the 96500, and that is called as Faraday's constant. So we need to understand and we need to remember this, that 1 mole of electron is called as 1 Faraday, and 1 mole of electron, 1 Faraday, is equal to 96500 coulomb, which is obtained by simply multiplying the 1 mole of electrons, that is 6.022 into 10 raised to 23, into the charge of the single electron. And the correct answer for this question, that is the relationship, is option C, that is Avogadro's number into charge is equal to 1 Faraday, which is equal to 96500 coulomb. So the correct answer for this question is option C. Now presenting question number 5 and level 2, and the question is: the maximum number of molecules is present in option A, 22.4 liter of H2 gas at STP, 5.6 liter ammonia gas at STP, option C 100 gram of calcium carbonate, and option D 36 gram of water. Dear friends, let us understand what is the concept. If we want to find out maximum number of molecule, first of all we need to remember that if the mole numbers are high, number of molecules will be more, and therefore in all the cases if we get the number of moles, we can easily say that what is the maximum number of molecule present. Now if we see various options, option A is 22.4 liter gas, hydrogen gas at STP. For any gas, if it is given standard temperature and pressure condition, then 22.4 liter represents 1 mole. So for A option, the 1 mole of gas is given. For B option, 5.6 liter ammonia gas is given at STP. 5.6 is 1/4 of the 22.4 liter, and therefore the mole numbers will be 1/4. It means 0.25 mole for the option B. When we see option C, 100 gram calcium carbonate. Dear friends, a gram molecular mass of any particular species, it means that molar mass of any particular molecule represent 1 mole. It means that if you want to find out calcium carbonate molar mass, it will come to 100 gram, 100 AMU, and therefore it is a gram molecular mass we call 100 gram. For calcium carbonate 100 gram, if we take, it is representing 1 mole, and therefore the option C 1 mole quantity is given. And when we see the D option, 36 gram of water, if we want to find out the mole of the 36 gram of water, we know that molecular mass of water is 18 gram. So 18 gram multiplied by 2, it becomes 36 gram. If we take 18 gram molar mass of water, it will be 1 mole. If we take 36 gram, it will be 2 mole. So when we compare all these mole numbers, highest number of moles are for water, that is 36 gram of water. If the mole numbers are high, the Avogadro number value will be double. So in this case, if the mole numbers are 2, then the value of molecules, that is 2 into Avogadro's number, and therefore the maximum number of molecules are present with the water, that is 36 gram of water. And the correct answer is option D, that is 36 gram of water. So such kind of questions are very important. They are oftenly asked in the various competitive examination, and just we can have to find out the mole numbers and then we get the answer. Now presenting question number 6, level 2, and the question is: arrange according to ascending order of the number of species present. A. 2 mole of nitrogen atom. B. 3 mole of nitrogen gas. C. 11.2 liter of nitrogen gas at STP. Options are option A, B less than A less than C, C less than A less than B, option C, A less than B less than C, and option D, C less than B less than A. Dear friends, we need to arrange number of species, not molecules, according to the ascending order. So we just need to find out what are the mole numbers. The highest mole number will be at the top part and lowest mole number will be at the bottom part. And if we are arranging from with the help of ascending order, then ascending order is that lower to higher. So first of all, let us find A, B and C mole numbers. So you can see that in question 8, 2 mole of nitrogen gas, nitrogen atoms are given. Option B, 3 mole of nitrogen gas is given, and option C, that is 11.2 liter of nitrogen gas is given. So 11.2 liter at STP, if we convert to the particular mole, it will be half mole, and therefore the correct order of ascending value of the number of species will be the lowest mole, that is 11.2, then 2 mole of nitrogen atoms, and then 3 mole of nitrogen gas. So correct order in code, if we define, it will be C is less than A is less than B, and the correct answer is option B, that is given as C is less than A is less than B, and this will be the ascending order. Now presenting 7th question, level 3, and the question is: remark on the statements given. A. Higher the molar mass, more the number of molecules present in it. B. Higher the volume of gas, more the number of molecules of gas present in it. C. Larger the molecule, more the number of atoms present in it. And options are given, that is A correct, B correct, C correct. Option B, A incorrect, B correct, C incorrect. Option C, A incorrect, B incorrect, C correct. And option D, A incorrect, B correct, and C correct. Dear friends, let us understand all the 3 statements and we will find the correctness of the statements. First statement is given that higher the molar mass, more the number of molecules present in it. It is definitely incorrect statement. If the molar mass is high, then we cannot say that number of molecules will be high, because gram molar mass is representing only 1 mole, whatever the substance is. Say for example, water has molar mass 18 gram and calcium carbonate has molar mass 100 gram. So if we count the mole of both of that, they will be 1 mole, and accordingly Avogadro number of molecules present in both the molecules. So higher the molar mass does not represent actually number of molecules. So option, that is the statement A, is given, which is incorrect statement. If we see the statement B, higher the volume of gas, more the number of molecules of gas present in it. Dear friends, it's a true statement that if we maintain the standard temperature and pressure condition, and if we take different gas, the one gas which is low volume and the one gas which is high volume, definitely their mole number changes, and if the mole number changes, number of molecules will changes. So higher the volume, more the number of molecules present in that particular gas, and it is a correct statement. So B statement is the correct statement. Looking at the C statement, larger the molecule, more the number of atoms present in it. Here the larger the molecule represent means the molecule has big molecular formula. For example, the molecular formula of water is H2O and the molecular formula of glucose is C6H12O6. It means that C6H12O6 is the larger molecule with comparison to water. If the molecule is larger, definitely the number of atoms present in it will be more because the composition will be formed because of more number of atoms, and therefore the larger the molecule, more the number of atoms present in is a true statement, and option C, that is the statement C, is the correct statement, and therefore the correct answer for this question will be D, that is A will be incorrect statement, B will be correct statement, and C will be correct statement. And this is all about today's 7 question session. Crack the 7. Now today's session add to brain points. Add to brain points are: number 1, the value. Avogadro's number has value 6.022 and to 10 raised to 23. Number 2, Avogadro's law, that is 1 mole of anything is equal to 6.022 into 10 raised to 23 number of that particular species. 1 mole of anything is equal to Avogadro value is equal to 22.4 liter of particular gas at STP, and 1 mole, that is Avogadro's value, is equal to 22.4 liter volume is equal to gram molar mass of that particular species. So this is Avogadro's law, that is second add to brain point. And third add to brain point is to application of this value in various numerical, that is you can find the maximum number of atoms and minimum number of atoms even any particular species by using this particular law. So maximum number of molecules, minimum number of molecules, ascending values, descending values can be obtained by this particular law. So to remember these particular values is very important for our studies. So do remember and prepare for the examination. Crack the 7.